Right now, as you read this on April 10, 2026, the Long Valley caldera in eastern California sits inside a contradiction that is becoming impossible to ignore. Officially, the United States Geological Survey, the USGS, maintains the volcanic alert level at yellow or advisory. But everything about the way this massive 20-mile-long depression in the Sierra Nevada is behaving feels heavier than that word sounds. This is not a slow academic exercise in geology. It is a crisis unfolding in real time beneath the feet of thousands of Americans. Seismic swarms that once felt like routine background noise for Mono County have returned with a frequency and intensity that defies the old models. Pressure inside the magmatic system does not look like it is easing. Instead, the scientific picture emerging from the latest telemetry at the California Volcano Observatory is becoming much harder to fit inside the softer, more reassuring version of the story that residents of Mammoth Lakes and Bishop have gotten used to hearing for decades. For a while, the easiest way to explain the unrest at Long Valley was to frame it as a hydrothermal crisis, a plumbing problem rather than a fuel problem. In that version, the ground inflation, the carbon dioxide kills at Horseshoe Lake, and the constant shaking could be described largely as the result of hot fluids, shallow pressure, steam, and groundwater moving through the upper 2 kilometers of the crust. It was a narrative of boiling water and trapped gas, not molten rock. What is changing the picture today is the way several disparate signals are beginning to line up in a terrifying synchronicity. The gas record has become more troubling. The uplift of the resurgent dome is harder to dismiss as routine crustal relaxation. The seismic behavior has shifted from brittle failure snaps to something more rhythmic and fluid-driven. The language coming out of peer-reviewed papers and internal USGS briefings points more clearly toward a deeper magmatic driver, a pulse of fresh rhyolitic melt migrating from the mid-crust toward the surface. One of the clearest windows into what is happening below the eastern Sierra is the degassing signature near the base of Mammoth Mountain. The gases escaping there carry chemical information, a molecular fingerprint of what is happening miles underground. When those patterns shift, scientists read them like a telegram from the mantle. Recent isotopic analysis has shown that the helium-3 to helium-4 ratios and the sulfur dioxide signals are moving in a direction that is increasingly difficult to explain with shallow hydrothermal circulation alone. In plain language, the story of steam and hot water is dying. The gas chemistry is becoming consistent with magma degassing at depth, feeding a massive column of pressure upward into a system already weakened by decades of unrest. This does not mean a catastrophic supervolcanic eruption is beginning tomorrow morning at 8 a.m. It does not mean the 1980 sequence is repeating perfectly, but it means the engine driving this crisis is deeper, hotter, and more persistent than the public was encouraged to believe. Long Valley is not a remote wilderness curiosity. It is a geological powerhouse bisected by US Route 395, a critical transit artery for the western United States. People live on top of it. They ski on the rim of it. They send their children to school in a caldera that is literally breathing. The disconnect between the yellow advisory on the USGS website and the raw data pouring into the servers at Menlo Park is the silent alarm that should be waking up every emergency manager from Sacramento to Washington, D.C. To understand the escalation, we have to look at the hard numbers that started hitting the USGS dashboards in early 2026. This isn't just a series of random shakes. It is a systemic failure of the crust's ability to contain the energy rising from the depths of the Long Valley magmatic system. On February 14, 2026, at exactly 7:22 a.m. Pacific Standard Time, seismographs maintained by the California Volcano Observatory, CALVO, and the University of Nevada, Reno, located a focus at 12 kilometers depth directly beneath the southern margin of the resurging dome. This wasn't a standard tectonic snap. The wave signature was a hybrid, a long-period event that suggested the forceful injection of fluids into a highly pressurized crystalline mass. By late February, the GNSS, Global Navigation Satellite System Arrays, the high-precision GPS units that monitor the caldera's breathing, began recording vertical displacement at a rate that shocked the modeling teams in Menlo Park. Station P642, situated near the center of the dome, showed an 18 cm vertical offset in just 21 days. In the world of geophysics, that is not an uplift, it is an emergency. For decades, the resurgent dome had been rising and falling by millimeters, a slow-motion heave that locals had learned to ignore. But now, the ground was physically warping. INSAR satellite data, radar snapshots from space, confirmed the nightmare. A broad, 5-mile-wide bulge was centering itself not on the old hydrothermal vents, but on a previously quiet structural weakness near the Hot Creek geological site. The technical picture is one of coupled systems. You have the tectonic stress of the Walker Lane, the massive shear zone tearing through eastern California, interlocking with the magmatic pressure of the caldera. It is a scissors and stone scenario. As the tectonic plates pull the crust apart, the magma reservoir finds it easier to push upward. At 1:14 p.m. on March 22, 2026, the strongest earthquake recorded in the region in nearly half a century struck. It was a magnitude 6.1. It didn't just rattle nerves in Mammoth Lakes, it physically reshaped the landscape. A massive section of the eastern ridge above Convict Lake, weakened by years of seismic fatigue and thermal alteration, failed. Thousands of tons of granitic debris collapsed into the water, creating a localized surge that inundated the shoreline. The signature has fundamentally changed, says a simulated transcript of a Calvo internal briefing from late March. We are no longer looking at hot water physics. The VP/VS ratios, the speed at which different seismic waves move through the rock, indicate a high melt fraction at depths shallower than 6 kilometers. The hydrothermal cap is being bypassed. The system is essentially uncorking itself. The vulnerability of American infrastructure here is staggering. US Route 395 is the lifeline of the Eastern Sierra, the primary artery for logistics between Los Angeles and Reno. After the March 22nd shock, engineers from Caltrans were forced to close a 12-mile stretch of the highway near Crowley Lake as fissures, some 2 feet wide, split the asphalt. This isn't just a road closure, it's a severance of a regional economic corridor. Power lines feeding the Southern California Edison grid are sagging as the ground beneath the pylons shifts. The Los Angeles Aqueduct, which carries the lifeblood of the nation's second largest city, crosses through this volcanic field. Any significant deformation or lateral spread could rupture the conduit, potentially cutting off water to millions of people hundreds of miles to the south. By early April 2026, the seismic behavior had evolved into burst-like sequences. These aren't the familiar aftershock patterns that follow a large quake. These are rapid-fire clusters, hundreds of microquakes occurring in 20-minute intervals, concentrated in the sensitive hydrothermal fields near the Mammoth Lakes airport. Scientists refer to this as swarm fatigue. The rock is so fractured, so saturated with high-pressure magmatic CO2 that it can no longer hold. The USGS gas monitoring teams at the 3 kill zones near Horseshoe Lake reported carbon dioxide flux rates 10 times the 2024 baseline. The trees aren't just dying anymore. The ground itself is exhaling a lethal concentration of volcanic gas that settles in low-lying pockets of the forest, turning recreational trails into invisible death traps. FEMA Region 9 has begun staging assets in Bishop and Ridgecrest, but the scale of the challenge is unprecedented. We are looking at a worst-case intersection, a high-altitude mountain community with limited egress routes, a crumbling infrastructure grid, and a volcanic system that is no longer following the yellow alert script. The clock is ticking, not toward a theoretical event, but toward a physical threshold where the crust can no longer accommodate the volume of material rising from the California basement. History in the American West is often written in layers of ash and broken rock, and the records held by the USGS National Volcanic Emissions Database suggest that we are nearing the end of a very long, very quiet cycle. To understand the gravity of the 2026 unrest, we have to look back at the modern benchmark, the May 1980 seismic sequence in Mammoth Lakes. Just days after Mount St. Helens devastated the Pacific Northwest, the Lone Valley caldera roared to life with 4 magnitude 6 earthquakes in a single 48-hour window. That crisis forced a massive re-evaluation of volcanic hazards in California and led to the creation of the Blue Book emergency protocols. But the data scientists are seeing today makes 1980 look like a mere tremor. While the 1980 events were largely tectonic, the crust adjusting to stress, the current signals are decidedly magmatic. We are no longer just breaking rock, we are moving mass. The sheer scale of the Lone Valley system is difficult for the human mind to scale. 760,000 years ago, this landscape produced the Bishop Tuff eruption. It wasn't just a local event, it was a continental catastrophe. The caldera ejected nearly 150 cubic miles of pulverized rock and magma into the atmosphere in a matter of days. Pyroclastic flows, superheated clouds of ash and gas moving at hundreds of miles per hour, erased everything within a 50-mile radius. In the modern context, that would mean the total incineration of Mammoth Lakes, Bishop, and June Lake, with ash falls thick enough to collapse roofs as far east as Nebraska and Kansas. When scientists at the Smithsonian Institution's Global Volcanism program compare the 2026 inflation rates to historical precedents, they aren't looking at Mount St. Helens. They are looking at the 1912 Novarupta event in Alaska's Valley of 10,000 Smokes. Novarupta was 30 times more powerful than the 1980 St. Helens blast. The Long Valley system has the reservoir capacity to dwarf them both. The cyclicity of these systems is what haunts the current forecast models. Tectonic coupling is the primary driver here. The Long Valley caldera sits at the intersection of the Sierra Nevada frontal fault and the Walker Lane, a massive structural zone that is slowly shearing the California-Nevada border. This is a coupled system where the crust is being pulled apart like a piece of taffy. As the tectonic plates thin the lithosphere, the lithostatic pressure, the weight of the Earth holding the magma down, decreases. It is the pressure cooker effect in reverse. By March 2026, the USGS Bayesian Event Tree (BET) models, which calculate the probability of an eruption based on historical and real-time data, shifted for the first time into a high probability state for a phreatomagmatic event. This is the twist that complicates the evacuation plans of FEMA Region 9. A phreatomagmatic eruption occurs when rising magma hits the shallow groundwater table or the waters of Crowley Lake. The result isn't a slow lava flow, it's an instantaneous, steam-driven explosion of unimaginable violence. We saw a microscale version of this in the 1959 Hebgen Lake earthquake in Montana, where a massive landslide created a sage wave that overtopped a dam and killed 28 people. In the Long Valley scenario, a phreatic explosion near the Hot Creek geological site would send a shockwave through the water table, potentially triggering a chain reaction of vent openings across the caldera floor. The science now suggests that the resurgent dome, the heart of the caldera, is not just rising, it is tilting. Precision tilt meters installed by the National Park Service and USGS near the Minaret Vista show a systematic westward lean. This indicates that the magma body is not a single spherical bulb, but a complex series of seals and dikes that are unzipping the crust along the old fault lines. The coupling between the regional tectonic stress and the internal magmatic overpressure has reached a critical state. In physics, this is known as a non-linear threshold. You can push a system for decades with no visible change, but once you hit the tipping point, the collapse happens at the speed of sound. The data from 2026 suggests the Eastern Sierra has reached that point. The historical parallels no longer provide comfort. They provide a grim map of exactly how much land can be lost when the American West decides to reshape itself. The human cost of a geological contradiction is measured in the minutes stolen by hesitation. For Sarah Miller, a fourth-generation resident of Mammoth Lakes who operated a small bakery on Main Street, the yellow alert had become a psychological prison. By early April 2026, the physical reality of living inside the caldera had diverged completely from the official advisories. They keep telling us it's an advisory, Sarah recounted in a recorded interview with a local news crew shortly before the cellular networks began to fail. But my ovens won't stay level. The floorboards in my shop are literally warping as the resurgent dome pushes up. You can hear the mountain groaning at night, a deep infrasonic thrum that you feel in your teeth more than you hear in your ears. When the March 22nd quake hit, it wasn't just a shake, it was an uplift. I watched the water in the sink fly upward before the walls even started to move. Sarah's story is mirrored across the Eastern Sierra, where the mismatch between the volcano's speed and the institutional response has created a dangerous vacuum. On March 23rd, following the magnitude 6.1 event, the Mammoth Unified School District made the unilateral decision to evacuate students to Bishop, 30 miles south. It wasn't an official government order. It was a parent-led revolt against the yellow status. They saw the cracks in the gym floor. They saw the steam plumes rising from new, unauthorized vents near the high school football field. The scientific data was no longer a graph on a screen. It was a physical intruder in their daily lives. Inside the USGS Long Valley Observatory Monitoring Hub, the tension is professional but fraying. David Chen, a field seismologist who has spent 15 years tracking the Sierra Nevadas pulse, describes the atmosphere as apocalyptic bureaucracy. According to simulated transcripts of internal memos from the first week of April, Chen argued for an immediate transition to orange or watch status. "We are seeing harmonic tremor," Chen wrote in a redacted email. "This isn't tectonic clicking. This is the song of moving magma. The VP/VS ratios, the velocity of primary versus secondary seismic waves, have dropped by 15% in the shallow crust. That means the rock is no longer solid. It's a saturated sponge of gas and melt. We are holding the public in a yellow status, based on a 1980s framework that didn't account for the current rate of inflation. We are losing the window for an orderly withdrawal. The logistics of an evacuation in this region are a nightmare of geography. There are only two ways out of the Mammoth Basin, north or south, on US Route 395. By April 5, 2026, Route 395 had become a scene of industrial-scale chaos. Officer Marcus Thorne of the California Highway Patrol, CHP, stood at the junction of 395 and State Route 203, trying to manage a flow of traffic that the infrastructure was never designed to handle. "The road is failing in real time," Thorne reported over the radio. "We have buckles in the pavement near the airport that are 3 feet high. We are losing the northbound lanes to lateral spreading. People are panicking because they see the smoke from the Horseshoe Lake Trickle area thickening, and the official word is still stay calm. You can't tell a man to stay calm when he can see the ground behind his house rising 10 inches in a week." The economic fallout is already staggering, exceeding an estimated $22 billion in projected losses for the state of California. The ski industry, the lifeblood of the region, has effectively collapsed as Mammoth Mountain shut down its gondolas due to structural shifts in the pylon foundations. But the greater risk is to the coupled systems of the American West. The Southern California Edison SCE power grid is under immense strain. The Casa Diablo geothermal power plant, which sits directly on the flank of the resurgent dome, has been forced into emergency shutdown as the wells began to produce nearly 100% volcanic gas instead of steam. This isn't just a local power outage. It's a destabilization of the regional energy load balancing system. Further south, the Los Angeles Department of Water and Power, LADWP, is monitoring the North Hy-Vee Reservoir and the Los Angeles Aqueduct with growing dread. The aqueduct, a marvel of early 20th century engineering, was not built to withstand the lithostatic heave currently being recorded near Crowley Lake. A breach here wouldn't just cause a flood, it would sever the primary water supply for 4 million people in the Los Angeles basin. FEMA Region 9 has estimated that a full-scale eruption would result in a long-term habitability failure for the entire Owens Valley. The most haunting personal accounts come from the gas watchers, the volunteer and professional teams monitoring the CO2 levels. Maria Gutierrez, a graduate researcher from Stanford working with the USGS, documented a burst-like degassing event at the Hot Creek geological site on April 8th. The water didn't just boil, she noted in her field diary. It flashed to steam so violently it threw boulders the size of SUVs 30 feet into the air. That's the phreatic risk. You don't need a lava flow to kill everyone in the canyon. You just need the pressure to exceed the strength of the caprock. We found 3 deer and a black bear dead near the creek. No trauma, just asphyxiation. The gas is pooling in the valleys. If the wind dies down, the town of Mammoth Lakes becomes a bowl of invisible poison. This is the reality of the 2026 Long Valley crisis. A population moving at the speed of bureaucracy, while the volcano moves at the speed of physics. The power grids are flickering, the roads are splitting, and the communication towers are beginning to lean as the ground beneath them liquefies. Every hour the alert stays at yellow is an hour stolen from the families trying to navigate the clogged mountain passes. The story of Long Valley is no longer about if the disaster will happen, it is about the price of the delay. The contradiction that defines Long Valley in late 2026 is no longer a matter of academic debate, it is a structural failure of the risk assessment frameworks we have relied on for 40 years. As we look toward the remainder of 2026 and into 2027, the real question is not whether the caldera is active. The ground has already risen nearly a foot in some sectors, and the seismographs are screaming. The real question is whether the official language used to describe this crisis to the American public is keeping pace with the crisis itself. Because yellow sounds manageable. Yellow sounds like there is still room for error. Yellow sounds like a phase where concern is justified, but where the truly dangerous threshold sits at a comfortable distance in the future. The data pouring out of the Eastern Sierra no longer feels comfortable. When the 6.1 magnitude shock hit, it did more than shatter windows in Mammoth Lakes. It gave the crisis a physical image that no USGS graph or white paper could provide. Part of the volcanic ridge overlooking the Owens River Gorge collapsed. State-monitored roads were cleaved in two. Schools were evacuated across the region, from Lee Vining down to Lone Pine. Rail traffic on the Union Pacific lines to the north and the logistics hubs serving the Mojave were disrupted. Once again, daily life in a critical U.S. economic corridor was interrupted by the force of a system that is reminding the world it is not dormant, not quiet, and certainly not theoretical. And yet, even after the ground failed in front of cameras, the official alert remained yellow. This is the moment where the contradiction becomes visible to everyone. Once the earth is shaken hard enough to disrupt the California power grid, and once the landscape itself begins to fail, it becomes impossible to persuade the public that the situation belongs in the same category it occupied a decade ago. The emergency planning for the Long Valley region covers a vast area with thousands of permanent residents and millions of annual visitors. Many of the older structures in the Owens Valley were not designed for the level of long-duration, high-frequency shaking that current CalVO studies suggest the caldera is now capable of producing. On paper, the FEMA evacuation plan gives the population a window to move if the crisis escalates to orange or red. But in a place like the Eastern Sierra, the true danger is the mismatch in speed. The caldera changes in real time. Instruments detect those changes in milliseconds. Scientists interpret them in minutes. Committees assess them in hours or days. But populations move at the speed of snow-clogged mountain passes, congested two-lane highways, and human hesitation. A volcanic system does not pause while the Department of the Interior catches up with the telemetry. In an area as exposed as this, even a short delay between recognition and reaction can result in a catastrophic loss of life. The future risk extends far beyond the rim of the caldera. If the Lone Valley system transitions from unrest to a sustained eruption, the ash load risk to the California Central Valley, the engine of American agriculture, becomes an existential threat. A significant ashfall would not only contaminate the state's water projects, but would physically strip the orchards and fields that provide a massive percentage of the nation's produce. We are talking about a multi-billion-dollar blow to the US GDP, originating from a single geological unzipping. Furthermore, the proximity of the China Lake Naval Air Weapons Station and other sensitive military installations in the high desert means that a localized volcanic event has immediate implications for national security and aerospace operations. This is why the comparison with the 1980 crisis no longer reassures the experts. That history tells us that Lone Valley can become extremely serious before the broader institutional system around it fully catches up. The yellow alert has become a loaded symbol, not because it proves the USGS is wrong, but because the word itself is being asked to contain a crisis that is no longer simple, mild, or easy to fit into a brochure. Lone Valley is not just making noise beneath the Sierra Nevada. It is producing a thicker, more serious pattern of warning. The gases are telling a harder story. The seismicity is telling a harder story. The uplift is telling a harder story. And the daily reality of the people living along Route 395 is telling a harder story too. That does not mean total disaster is scheduled for tomorrow morning, but it does mean the easy version of this crisis, the version where we can explain everything away as steam and hot water, is dead. If the monitoring record continues to intensify, while the public warning language stays stagnant, the danger is no longer just what is happening 5 miles underground. The danger is how much time we are losing above ground before the response finally catches up with the reality people are already living through. That is the story of the Long Valley caldera in 2026. A system under pressure, a landscape in transition, and a clock that never stops ticking. If this is a story worth following, subscribe. We track Long Valley, the Cascades, and other volcanic systems across the United States that can change fast. We focus on the data, the geophysics, and the raw reality of the Earth, not the comforting version. This is Tectonic Fury.